Alrighty guys, now for something completely different. You Python programmers and you Java programmers have never gotten to do this using pointers. A pointer, periodically I've been talking about, well, the address of this variable is, or, we're going to store the address of this whatever inside the array. The address, you find it by using a pointer. This little symbol here means give me the address of the number variable. So what you do is you declare a variable and then you can get the address of that variable. Your first question may be, well, why do I care? Just bear with me for a little while. So a pointer variable, often just called a pointer, it's a variable that holds an address rather than a value. So you can have an int and then you can have a pointer to that int. The pointer variable holds the address of another piece of data. It points to that data. And you can access that data and you can change it via the pointer. And that's not such a big deal in the kind of code we've been writing where we had a main method and we had some values in it and we changed them directly. But you can pass pointers to functions so that the function can change the value. And why that's necessary, we will demonstrate. So far, we've already worked with something similar to pointers, which is when we passed arrays as arguments to functions. And honestly, I don't remember how often we did that. We may need to throw in one more example of that. For example, suppose we use this statement to pass the array numbers to the showValues function. So we've written a function called showValues. We're passing an array called numbers to it. And then we say, okay, here's the size of the array. So it's got 10 elements. I want you to print out 10 of them. What happens is the address of that array gets passed in to the function so that it can use it. Otherwise, how would it access that array? It's not that the entire array gets copied. What if you had an array full of 10,000 elements and then you call showValues? You don't want all 10,000 of those elements to be copied. That'd be like saying every time I'm going to give you a book, I have to run to the photocopying machine and make a copy of every page on the book. No, you just want to hand them the book. We just want to hand them the address to the array. And so the compiler handles that automatically. When you pass in an array, it's bringing in the address so that then we can iterate through the array inside the function. We've also worked with something like pointers when we learned to use reference variables, except we didn't. So I'm going to skip that section. So pointer variables are another way of using a memory address to work with a piece of data. They're more low-level than arrays and reference variables. Reference variables were not invented until a long time after pointers were. This means you are responsible for finding the address you want to store in the pointer and correctly using it. You are responsible for doing it correctly, it should be saying, and it should put this in all caps. Because if you mess your pointers up, then you can cause your program to crash. Just like writing past the end of an array can cause your program to crash. So let's demonstrate getting the address of a variable using a pointer. So I'm going to make a new project. My boilerplate hasn't been updated in a while. Alrighty, I believe that I've got all my good stuff here. I'm going to make a variable. Maybe I'll even make several. Int x is equal to 1. Or 1, int y is equal to 2, double d is equal to 3.0, double e is equal to 4.0. So we could write those values out really easily, Cout x endl, Cout Y, ENDL, Cout D, ENDL, Cout E, ENDL. But then copy those 4 Couts and paste them. And in front of all of the variables, put ampersands. So I'm going to copy those 4 lines of code, paste them, and I'm going to put an ampersand in front of each one. This is going to print out the value of the x variable, which is 1. This is going to print out the value of the y variable, which is 2. This is going to print out the value of the d variable, which is 3, and that's going to print out the value of the e variable, which is 4. This is going to print out the address of that variable because we know it's residing somewhere out in the, in the RAM of your computer, and each byte of your computer has its own address, so we're going to see what the addresses of these variables are. And since I didn't put a system pause, it's going to run by it, close it, scroll down here, system pause. I could avoid that by doing run without debugging. For some reason, the debugger doesn't keep the window open, and run start without debugging does, but alrighty. Here we go. There we go. Values 1, 2, 3, and 4. And out in RAM, those numbers are stored in these memory addresses. And it's kind of weird. It's like they're in inverse order, right? That was the 4. That was the 3. That's the 2. See, they're descending in value. But you cannot predict where the compiler is going to place a particular variable or where it's going to wind up in the computer. So these could have been in any order whatsoever. We just absolutely cannot trust, these values to be in any particular order. But we can see the memory addresses that these values are stored in. So big deal. Let's go and create a variable that holds a pointer to x and to y. So I'm going to scroll down here above my last print statement, my last cout, and I'm going to declare a pointer to my x variable. And it's equal to ampersand x. And I realize that these may be abstract concepts, and I'm not expecting everybody to have them 100% in your brain. Do go and read this chapter. Excuse me, I need to change that to a double because D was a double, not an int. Oh, I goofed that one. There we go. Now, if I print out PX, PY, PD, and PE, I'm going to get the same thing that I got with that. You may as well just copy those 4 cout statements again. Save some time, paste them, but make them print out PX, PY, PD, and PE. And we're going to see the same numbers because these variables are not integers. It's a pointer to an integer. This is not a double, it's a pointer to a double. And which double is it pointing to? It's pointing to D. And so yeah, it just printed out the same values again. same memory addresses. Okay, so we can use those pointers to actually change the original data. Nowhere else in the C language, C++ so far, I'm going to type something, but don't type this, have we seen this behavior. And I'm going to reiterate, don't type this. Int s is equal to 10, int t, or int whatever, and then y is equal to 20, and then if we printed s out, s would magically become 20. We've never seen behavior like that before, but we're going to see it now. We're going to change the value of x to something else. We're going to say star px is equal to, well, it used to equal 1. That's boring. Let's make it 100. And then let's print out x. And there we go. X changed from 1 to 100 without even using the x variable. Right? I didn't say x is equal to 100. I said using the address that is stored in this pointer variable, set the data that is stored at that memory address equal to 100. And it just happens to be the x variable. What if we didn't make px equal to the address of x? What if we made px equal to the address of y? I'm going to do that here. Px is equal to the address, the ampersand, of y. Now I'm going to set star px equal to 200. And then I'm going to print out y. I think I'll just copy that line and paste it to save time for typing. New value for y. So when I run it, it's going to say that the new value for x is 100 and the new value for y is 200. And isn't that weird? I mean, it's not. But notice that we changed the value of y to 200 even though we don't even see the letter y anywhere in that line of code. And the reason why it's working is the address of y is stored in this variable. And we can use that address and overwrite that value that that address is pointing to like that. And again, that's not too useful just in main like that. Why would we want to say star px is equal to 100 if we could just do x equals 100, right? Or why would we want to do this if we could just say y is equal to 200? Where it becomes useful is when writing functions. So I'm going to come down here and write a function. Since I'm putting it after main, I'm going to then have to go and add a prototype to the top. I'm going to make it void because it's not going to do anything really useful. And we're going to call it change me. Change me 1. Change me 1 is not going to work. We're going to take a variable x and we're going to change its value. And here's the way that I want it to work. I want to be able to do this. Change me 1, parentheses x, and then if I print out new value for x again, I'd like for it to say 1000, but it's not going to. I do need to put a parameter, a prototype, up at the top of the code, since I put my function down below main. And I did that because I still hear people typing from this line of code. I'm going to go ahead and do that though. I'm going to grab the header for that function, copy it, come up above main, paste it, and put a semicolon there. So that's our prototype. Now I'm going to run down here, run it, and prove that that's the case. I know it makes it hard to read when I do that, but I really need to try to get it all on the screen. Okay, there we go. There we go. I called change me. I wanted to see that X had gotten set to 1000, but it didn't work. Why is that? Because X just gets a copy of the value. At this point, X contains the value 100. We proved that by printing it out here. And so when we get here, this X gets a copy of that value. It's equal to 100. We can change it, but this was just a copy. It's like somebody hands you a copy of a coloring book. You can, tear the book up. Somebody else still has the original. So this is not the original variable. It's just a copy of it. The fact that it's called X doesn't mean anything. We could call this anything. We could call it Fred, because this parameter is just a copy of the argument that's passed to it. That's because what this is doing is pass by copy or pass by value. This is the more common term, pass by value. But it's copying that value into it. So whatever is here gets copied into that. If we passed Y in instead, it would pass in 200 into it rather than 1. We can change it, but that doesn't matter. This is just a copy, just like you give somebody a copy of the Declaration of Independence and then they scribble stuff on it. You still have the original. It didn't matter. By the time we come to here and we print out X or we print out Y, they have not been changed. And what if we want this function to be able to change it? Well, there's a way to do that. We're going to write a new version of change me. And I'm going to pause here and make sure that everybody's got it working. Anybody need help typing?
I just need to see what the prototype looks like.
Here, the prototype is just the header with a semicolon at the end, like that. So just go and put that up at the top. While we're at it, let's add the prototype for the one that we're just about to write. Excuse me, that's supposed to be a star. My mistake. Right? Is that how I did it down here? Yes. But I'm going to call it px because it's not a variable itself. It's a pointer. So that's my prototype.
What does the star do?
The star means that this is a pointer. It's not an integer. It's a pointer to an integer.
Okay.
I know it's a weird thing. So, heck, while we're here, we may as well write change me up here at the top because we're already looking at it. So what we're going to do is we're going to say star px is equal to 2000. And let's prove that that works. Let's just make another integer, not mess with our current ones. Int a is equal to 0. Change me to ampersand a. Pass the address of that variable in so that we can store it in a pointer and use that pointer to change that value. Now when we print out a, it's going to say that it's 2000. And hopefully you do see it right there. Whereas, if we had called change me rather than change me to, change me 1 like that, and we just passed in a, that function can't change the value of a because we're not passing in the address, we're just passing in a copy of the value. So if you ever need to write a function that's going to change the data of what you're passing in, pointers is one way to do it. It's not the only way, but it's one way. And so sometimes what people will say, and it's a totally legit point, is, well, why didn't you just return 1,000 here? Yeah, you can do that, but we already know how to return values. What if we needed to change 3 different values? So we're going to write a change me that changes 3 different variables. Void change 3, int star px, int star py, int star pz, and so star px is going to be set to 98. Star py is going to be set to 99, and star pz is going to be set to 100. So whatever 3 integers are passed in as pointers, we will be overwriting their values. Let's declare 3 more variables and prove that. I'm going to do it up above. I know that makes our code backwards, but that's all right. Int v1, v2, v3. Change all 3 of these variables. Change 3, ampersand v1, ampersand v2, ampersand v3. And then if we printed them out, they would equal 98 plus 99, 98, 99, and 100. So C out, V1, followed by a space, followed by V2, followed by a space, followed by V3, followed by ENDL. And it's going to print out 98, 99, and 100. If we tried to do this without pointers, it wouldn't work. In fact, it wouldn't be able to print out anything because these guys haven't been assigned any values yet. All right, so we do see 98, 99, and 100. We are seeing that a function can change the values of data if its parameters are declared as pointers. Hope that makes sense. Read the book to get the idea hammered in. This is old school programming. This is C programming from 1970. There are other ways of handling this need besides pointers. But pointers are an efficient way of passing data around. So game programmers often use pointers in order to pass around large chunks of data. You know, like images, things like that. Okay, there's something else called reference variables. You know, this syntax is pretty alien. Olivia's going, why are you putting the stars there? Why are you putting all the ampersands here? You can write your code in such a way that you don't have to do all that, and then the function can still change the value. We're going to write another change method that does it via references. So void change R, because it's going to use references. And so I think I have the syntax for this wrong. Uno momento. I think it's the ampersand. I just did C# there. Doesn't help y'all. Yeah, it's an ampersand. So this, you have to use the syntax a little bit different, but anyways. Okay, so int ampersand. I feel like being different. Instead of using x, I'm going to use the word variable. But then we can say variable is equal to 999, whatever value we want to change it to. And now we can use that. I'm going to declare a new variable, int my weight. I'm going to wind up weighing 999. I'm not going to be happy about that, but that's okay. Change r, and I'm going to pass in my weight variable. And then I'm going to print it out. Weight equals. When I run that, it's going to say that weight is equal to 999. This syntax still took a little bit different, right? We had to put that ampersand there. But once we did that, we didn't have to do any monkeying with asterisks there. And we didn't have to put any ampersands or anything down here. This syntax is a lot cleaner. This was introduced with C++, you know, decade and a half after C was invented. So this changes it. This is doing pass by reference. The ampersand means I'm passing in a reference, which means I'm actually getting the address of the variable so that I can change it. Whereas if we'd done it without the ampersand and we ran it, well, let's do it both ways. I'm going to run it and make sure it says weight. Oh, look at that. It didn't say weight is equal to 999. It just says weight equals.
You left out your variable, I think, on the CI statement.
That would do it. Thank you. All right, because my faith in the universe was momentarily shattered. Now it's brought back. Okay, weight is equal to 99. Okay, hope you saw that. I had to add that. Thank you, Olivia. But if I took that ampersand out, it's not going to work. Even giving me an error. And the error is that this variable has not been initialized. So if I set it equal to 0 there, why wasn't it initialized? Well, because we never assigned it a value, and when we went in here, we could change this, but this was just a copy of whatever we passed in, which was an uninitialized variable. And so it still says weight is equal to 0. If I restore my ampersand, it changes it. So references can be very useful. They allow you to actually pass in the variable itself. Probably because I haven't saved it. Okay, yeah, once I saved it, that error went away. Let's make some notes. That's the wrong notes, and I need to tell you all this as well. For my classes, I'm giving an extra 3 points of final exam credit. If you upload a note into a Dropbox that I'm going to make saying which CIT core classes you are enrolled in for the spring semester, or if you're taking an intersession course, that would count as well. I'm not teaching any intersession courses. I'm not sure which ones are available, but you may find one that you want to take. I'll make a Dropbox for this, so that if you're already enrolled in any spring classes, go ahead, upload a note. You're going to get that extra credit on your final. If you're not enrolled in any classes yet, but you want that credit, go ahead and enroll.
So do we just have to say like what class?
Yeah, just tell me the class. I trust you. I'm not going to ask you to take a photocopy of your schedule and give it to me, but I can check if I want to. Okay, so I really do need to make the Dropbox for that for all of my classes. Anyways, let's make some notes. I need to save this one. No, I don't, because all of that is some stuff that we don't care about. Okay, so a pointer is an address to a variable. To declare a pointer, you use the asterisk, like this. Int star px. This is a common nomenclature, meaning that this is pointer to a variable named x. Do you have to follow that convention? You could just call this Fred. Yeah. And it would still work the same way. But if you do this, consistently, then people know, okay, somewhere I have an x variable and now this is going to be a pointer to an x. But maybe it's not going to be pointing to x. I mean, you can name your pointer anything you want. You know, int star pointer. A pointer to some integer. We don't know what integer it's pointing to. But this is a pointer to an integer variable. And so is that one. And how do you get the address of a variable? You use the ampersand. So px is equal to the ampersand of some integer that you've declared. Pointer is equal to the ampersand of some variable that you've declared, the address of your weight variable or whatever. Why do I have this off to the side? Using pointers, you can change the value that is stored at that address. So if you do this, star pointer is equal to 100, this will change the value of the weight variable to 100. If you do star p x is equal to 90, that will change the value of the x variable to 90. So I'm going to write a little bit of code. That syntax may not be entirely correct, so I'm going to make absolutely sure it is. Okay. Okay, so now if I print out age, weight, and height, what is it going to print out? Assume that there are spaces between them, even though there's not here. Alrighty, I see a lot of people not looking up here to not look at my little thought problem. When this is all done, what does age equal? It's equal to 300. How do I know that? Because Wilma contains the address of the age variable, and then we set the value that that's pointing to 300. So age is 300. Pretty weird, but okay. Maybe it's 300 months, who knows. What is the value of the weight variable? Yeah, 200, because Barney's got the address of the weight, and so when we add, this is known as dereferencing, a weird term, but we dereference the Barney pointer to store that value in it. I always prefix my pointers with P's. And then you know that when you see that star there, if you're going to change it, and I'll show you what that would look like. Yeah, star P, they cancel each other out. You know, if they, if you do px is equal to x, py is equal to y, or whatever. But in this case, I didn't. I wanted to make it a little bit of a thought problem. And so the height is what? Obviously it's going to be the 6, right? But why is it 6? Because Fred contains the address of the height variable. So when we dereference it to get the address of the Fred variable and to change it, we're changing the height to 6. So this would print out 300, 206. Let's see what else the PowerPoint has to inflict on us about pointers. So, integer star int pointer. You read this as int pointer can hold the address of an int, or it's a pointer to an int. Spacing doesn't matter. If you like doing that, that's great. If you like doing that, that's great. You can initialize pointer variables with the special value null pointer. That just sets it equal to 0, but it means that something has not been initialized yet. You can't change it if it's got a null value in it. Let's kind of prove that to ourselves. I don't necessarily want you to type this because I'm expecting it to crash, but we had change 2 here. That was changing this. I'm going to declare a pointer. Nah. Changing my mind. But anyways, so int hello, and then int star p hello is equal to null pointer, and then I'm going to try to change that. P hello is equal to, 30. Is that going to work? No, because it's not pointing anything. That should give me an error. Boom. Access violation writing location. So when you create pointers, if you're not initializing their values immediately, go ahead and set them equal to that special value. It's just like assigning your integers or your doubles 0 or whatever. It does initialize it, but if you try to write to it, it breaks. What would I do? How would I change this if I actually wanted this to set my hello variable to 30? I'd have to make a change here. I would not assign it to null pointer. I would assign it what? No. I wanted to change the hello variable here. So I'm going to do not hello. That's close though. I need to do something else. I need to put the address symbol here. That gets the address of the hello symbol so that we can store it in the pointer. Now when we did that, if we printed out hello, hello would be 30. And we did that through our examples here. Wherever they went. Right. We use the ampersands to say it. You're not equal to the height variable. You're containing the address of the height variable. You're not equal to the age variable. You're containing the address of the age variable. So what do people use pointers and references for? Well, if you have a return statement, all you can do in this language is return one value, right? You can't return 2, 3, or 4 values. This kind of stuff lets you return more than one value. We have a function here that's effectively returning 3 values. What do I mean by you can only return one value? If I have this int divide, and it's going to take 2 integers and return the result of those things divided by each other. Int result is equal to a divided by b, return result. That's all I can do. That's all I can make it do is return one value. I can't chain a whole bunch of variables in order to get them to return them. Well, when might you want to return more than one thing? What if you wanted to be able to pass back the idea that an error occurred? Like what if they set b equal to 0? If they set b equal to 0, this is going to crash. And that's not really what we want to do. So this is an unsafe version. And you could solve this with either pointers or references, but since the reference syntax is a little bit cleaner, as we saw, I'm going to write it as a reference. I'm going to call this one safe divide. It's going to take an A, a B, and then it's going to have something called result. So, when does our problem occur? When b is equal to 0. That's our error condition. So if b is equal to 0, we have a problem, and we want to return false. Else, we have good stuff, right? So we can say the result is equal to a divided by b, and then we can return true. So when we call that method, we can check to see whether it worked or not. We're returning the success state with a return statement, but we're returning our answer, our result, as a reference parameter. And we could have done the same thing with pointers, right? I would just put a star there, and then we would put, star result is equal to there. It'd work either way. So when you invoke that, you would invoke it like this. I don't know how to get all this code on the same screen at the same time, so I'm just going to write another test function. Void test. I would do this. Bool, okay. And then I would need something to hold my answer. Int r. And then I could do OK is equal to safe divide 3 by 0 and store the result in the r variable. And then if it's okay, great. Print out, see out the answer. I'm going to change r to answer. Quite get it all on one page. If I could get this little debug bar up there, would that make room for everything? I don't even know what that window does. I'll bring them back when I need them, I guess. Well, I've lost my little green run. But anyways, that's how you can write a function that returns more than one result. It's returning a success or a failure, but it's also putting the answer in a reference variable. Now, old school programmers would try to do something like this. Okay, if it's great, I'm going to return the answer, else I'm going to return -1. -1 means it's an error. Well, that doesn't work if -1 is actually possible, right? You could divide two numbers and get -1 as a result, so you couldn't use -1 as an error code. So then you start monkeying around. You go, okay, if it returns a -99999, that's an error condition, otherwise it's a good thing. No, you don't want to do that anymore. You don't want to hard code special values for your returns and then have to check those special values to see if it got a good value. The only exception, or the commonly used one, is if you're searching for something and you don't find it, then the answer is -1. You'll see that used a lot. But otherwise, you can do something like this in this language to pass the result back. Now, I didn't stick this in main, so we can't even test it and run it, but I think that's okay. Hope you got that point. If not, the takeaway is why do you use ampersands and references? Why do you use references and pointers? So that your function can actually change values. Why is that a good thing? because otherwise you can't change the value because you're only getting copies of the values. And so why is it a good thing really? Is so that the function has the ability to return more than one value, or to modify the data with more than just a return statement. Returns are great and all that, but sometimes you want to do more than that. Clear as crystal, clear as muddy water, or clear as cement? Yeah, sorry. You better read that chapter. So here they're calling the asterisk the indirection operator. And here's the nice programmer term. Go home and tell your kid or your parent or your partner, the indirection operator dereferences a pointer. Then they'll look at you like you're crazy. But we know what that means. This is a pointer to the address of the x variable. So if we want to print out that variable, we have to prefix it with the star, also known as the indirection operator. Relationships between arrays and pointers. I don't know if I want to talk about this. Do I have to? I think that'll just confuse the issue. Maybe not. Let's take a stab at it. It's not something I'm going to put on the test, but I want you to be exposed to it. So let me find main. Scroll up and down, scroll up and down. I'm going to declare an array of integers. Constant. Nah, I'm not going to even make it that fancy. Int numbers is equal to, and we're going to stick 3 numbers in, 10, 20, 30. We know how to get the first value out. How would I print that first value out? What would I put there?
0.
We'd put a 0 and that would work. But what would happen if we did this? Cout, I need to look at the cheat sheet. Alrighty. Cout asterisk numbers. That's going to print 10. That's pretty counterintuitive. I'm trying something, don't. Got to see if that'll actually work now that I've removed all my bars. How do I get my toolbars back? Well, I guess I run it with debug. Start debugging. Well, that didn't work. Let me take another stab at it.
You have to use PTR.
Pardon me?
You have to do numbers PTR.
I could make a pointer to the array, yes, and do that. How about if I did it this way? Yep. This is just demonstrating that in this language, an array, all it is a pointer. And that's why we don't have an easy way to get the length. Yeah, we do if we divide the size of the array by the size of the, of each element, but that doesn't even work in all cases. If you're passing in the array into a function, you may not be able to calculate the length of the array in that fashion, which is why the textbook shows writing functions so that you pass in the length of the array if you're going to be processing it. So this is saying this is the address. Numbers is the address of the array. So if I print it out, well, the first element in the array is a 10. And this is saying, okay, take that pointer, but I want the second address. Dereference it, and that one's equal to a 20. Change that one to a 30. Okay, so what the textbook did show doing it a slightly different way. Here's what it showed. Int p numbers, or int star p numbers, is equal to numbers. And then you can access p numbers just like it was an array. You could see out p numbers 0, p numbers 1, and p numbers 2. And it's going to print out 10, 20, 30, all in the same line. Like that. So it's weird that this is considered the same thing as declaring it like that, because we could have declared, a second reference to that array like this. It's numbers is equal to numbers, right? And then, that doesn't actually copy that array into that. And in fact, that's an error. Okay. I'd have to think about why. Okay. So anyways, you can access arrays using pointers. We see an example of that here. We also see an example of assigning that array into a pointer variable and then treating that pointer as though it were an array, which is kind of curious to me. I'm going to just mess around, and if you feel like typing it, that's great. If you don't, that's also fine. Int Joe is equal to 2, Bob is equal to 3, Carol is equal to 4. Now I'm going to declare a pointer to Bob. Int star pbob is equal to the address of Bob. Now what happens if I print out pbob element 0 plus a space plus pbob element 1, ENDL. This is just total playing. My question is what do we think that's going to print out? Well, what should this print out? I think that's going to print out a 3. The question is this going to print out a 4? Or is it going to print out a 2? Or is it going to blow up? Well, I'm going to find out. Like I said, that was just playtime. I have to find out what it does. Yeah, nothing useful. Okay, so forget I even did that. But I guess it's worth seeing that. So we are seeing that you could dereference a pointer like this, star pbob, or like this. Those two things do the exact same thing. And I know this is pretty abstract. I know that we're slipping towards the clear as concrete. So array elements can be accessed in many ways. You can give the array name, followed by the square braces. You can use a pointer to the array in square braces. You can use the name plus that syntax, or you could use the pointer to the array in subscript arithmetic. All four of those do the exact same thing. Now, to my mind, they're all absolutely absurd. That's the way that every other language does it. That's how you've learned it in Python or Java or whatever. That's how I want you to remember it. But all these others do the exact same thing as well. And like I said, if you get into a job where you're a C++ programmer, you will probably run into a circumstance where you're doing pointer programming. It's well worth reading this chapter a couple of times, hoping that some of it sticks. One, so that you can get a couple more points on the exam. I'm not going to have a huge number of questions about pointers on the exam. And then two, so that you could look it up if you needed to. But people who have gone on from this college to take courses at another college that expected them to do C programming rather than C++ programming, and they think, well, I took C++, that means that I know how to do C. C is all about pointers because it didn't have fancy things like references and classes and things like that that solve these problems. So you got to learn pointers if you're going to be a C programmer. And are there a lot of C programmers out there? Yeah, there are. But isn't C++ better? It is in a lot of ways, but it takes more memory in order to support all those classes and stuff like that. Linux is written entirely in the C language rather than the C++ language because the people who write Linux think that it's easier to prove and to debug the code if it's written in C rather than C++. And to them, I'm sure it is. There are a lot of people who do programming in C. Therefore, there are a lot of people who are still using pointers and stuff like that, 40, 50 years after they were first invented. Pointer arithmetic. I want to talk about pointer arithmetic. Initializing pointers. We've done that, but that's a good point. If you, no pun intended, if you have a pointer, I'll scroll to some blank spot. I don't care if we get this to work because this is going to be a syntax error, so I'm going to wind up deleting it. If I have a variable for my temperature, and then I declare a pointer to it, int star ptemp. And then later on I think, well, I need temperatures to be more precise than 98. I needed to say 98.6, so I'm going to change that to a float or a double. When I do this, it's not going to work anymore. This will not compile. Why? Because this is a double, but we're trying to store the address to an int into a double. Why does it matter? Well, a double is a fundamentally different type. It's a floating point rather than an int, which is stored completely differently in memory. And another thing is it's twice as wide. It's an 8-byte data type rather than a 4-byte data type. They're just not. It's just cats and dogs living together, and you can't do that. So, I'm sorry, that's a Ghostbusters reference, and it's stupid. Anyway, so here we have pointer to an int, and we're trying to stick the address of a double in it. That's an error. It will not compile. If we wanted this to work, we would have to change that to a double. Double star ptemp is equal to ampersand temperature. I think we're going to hit this topic a little bit more the next time we meet, but I'm not going to give you any pointer homework. You're going, whew, I'm glad about that. But I think I will put, we will have to throw up a little quiz about pointers so that you will have to, regurgitate some information about it. Try to get it to stick in your head in case you need it in the future. The big deal about pointers, not the big deal, the most common use you'll see is the ability to change data like we did here. So this is the syntax you're going to see the most common. You declare some parameters, but you make them pointers so that you can then change the values of them by that. And if I could beg y'all to memorize one thing, it would be that. Take that, hang it on your fridge, brag about how awesome it is that you understand that code. Alrighty guys, why don't we call ourselves done? And I know for some of y'all it did click like that. I know for some of y'all it didn't. That doesn't mean you can't be a good programmer. It just means that this is a pretty weird concept for people who have learned other programming languages. If you learn Java or Python first, then when you hit pointers, it's not going to make quite as much sense. And I'm not trying to talk them up as being hard to understand, which I know I have, so I apologize for that. Everybody can understand them, but it would take some additional reading and some additional playing for it to click for some of y'all. Just remember that it's a way to access a value directly by its memory address. Like giving somebody the address to your home so that they can go and, visit your home directly, rather than giving them a copy of your home.
Can you print me a copy of the code too?
Absolutely.
Can you do it from inside? You're not using that piece. Never mind. Sorry.
Sure. Why would it have mattered?
No.
I'm not challenging you, but why would you care if I printed it from inside NetBeans?
No. Because I printed the Java code. I copied and put it into Word.
Yeah.
It really spaced out.
Yeah, you're right. It spaces out horribly. Fortunately, when we copy and paste out of Visual Studio, it looks pretty good.
Okay. Never mind. I guess that's because Visual Studio is a Microsoft.
Yeah. All right, here's all 7,000 lines of code. And I can help you fix any bugs and stuff like that. Anybody need any syntax errors out of the 2,000 lines of code that we typed that you want help fixing? I guess not. I see people checking their phones and anxiously wanting to go. So I will see y'all on Tuesday. I know that you have one more homework assignment. Not one more. One that was due on December 3. So go ahead and get that done. It was over arrays. It's pretty elementary compared to where we are now. Pardon me?
Was that the rainfall?
Yeah, right.
The Word documents that went along with them were slightly different. They were not the same.
Oh, do you mean the PDF and the doc are different?
Yeah,
That means you get to pick the easier. No, I'm kidding. I did not mean that to be the case.
This was one of them. This was the two-dimensional arrays, and then this is the rainfall.
So there are two Word docs in the same folder?
No, you actually have them listed twice. You have two number 13s. These guys are up there.
Okay.
Yeah. Okay. So the whole is 13.
Oh, rainfall with arrays, right.
Yeah, 13 is a rainfall and this two-dimensional arrays.
Oh, brilliant. Okay, pick the easier one. No,
That's what I got out of that.
I'll modify them.